Welcome everyone, today 7F.2. So I've got a couple examples up here. 1B is a broken question, so we won't worry about that one. I'm not sure what I was thinking when I wrote it. Must be missing something simple somewhere, but it's broken. So we're talking about equality of complex numbers. And so over here I've got one complex number, and over here I've got another complex number. What's a complex number? It's got real parts and imaginary parts. And so if we have two complex numbers equal to one another, then the real part has to be equal and the imaginary part has to be equal. So the real part of this one is 3x and the real part of this one is 12. So we have x is 4. And the imaginary part of this one is minus root 5. And the imaginary part of this one is y. So we have x is 4 and y is negative root 5. Okay, now we're told here a plus bi, z is a plus bi, that's a complex number. And they want us to find it in, find the complex number a plus bi, okay, given this statement is true. So if z is a plus bi, then what we're going to have is 5 times a plus bi, take 14i, equals 3, take a plus bi times by I. Alright, so all I've done is substitute z in there. Our complex number z is represented as a plus bi. We're going to expand this, okay, and try and get everything sort of on one side altogether. So let's go ahead here. Here I'm going to have 5a plus 5bi, take 14i, equals 3, take ai, take bi squared. Okay, so here's what we're going to do. We're going to try and get the a's and b's on the left side and just the numbers on the right side so that we can isolate each respective part. Now when we have, so I'm just moving along here, I'm going to keep 5a plus 5bi, and I'm going to shove this minus 14i over this side. So over here we're going to have 14i plus 3. We have take ai, and we have take bi squared. What is I squared but minus 1, isn't it? So it's take b times minus 1, it becomes plus b. And I've said we want to put the a's and b's on the left side. So I'm going to move both of these terms over. So we're going to have 5a plus 5bi plus ai, take b, equals 3 plus 14i. Okay, so I've just moved the a's and b's over, and I'm going to put the real parts together and the imaginary parts together. So the real part is going to be 5a take b. It's the real part because there's no I associated with it. 5a take b, that's the real part. And the imaginary part is going to be 5b plus a. I'm going to put it in brackets with an I. That's the imaginary part. Okay, so I've just collected things over there. And on this side, we have 3 plus 14i. Okay, any questions at this stage? Because now we're going to launch into a different process. So all we've done there, we've plugged a plus b in, we've expanded, we've switched things around until we've isolated the real parts and the imaginary parts, and we've got the a's and b's on one side and the numbers on the other. Now we said, this was our first proposition, is that with a complex number, all right, if they're equal, then the real parts are equal and the imaginary parts are equal. So this is the real part over here, 5a take b, it has to equal 3. Okay, that's our first equation. 5a take b equals 3. And our second equation, 5b plus a, the imaginary part, has to equal 14. Now, if we're going to put that, now we could go ahead and try and sort of solve that manually, but I'm not so interested in doing simultaneous equations here. I just want to do it really quickly. So we'll put it in our calculator. But if we want to put it in our calculator, we need to make sure the A's and B's line up. So this is A plus 5B. There's a best way to write it. A plus 5B. So I've got A's and A's and B's and B's in the same column. Now the way we put this in our calculator, follow along, this is a skill we're going to keep coming back to relentlessly throughout the rest of this term and into year 12. So we'll do menu, equation solver. This is a simultaneous equation and there are two unknowns. What we put in our calculator is the number 5 minus 1, 3, 1, 5, 14. And you can see the relationship between that and that. And then that's going to generate the solutions for us, A and B. And from memory, they're sort of rational. Does someone crunch that for me?
29 on 26.
For A, thank you.
For X. Well, yeah, A.
Yep.
67 over 26.
Excellent. Okay. So that'd be a pretty nasty one to find manually anyway. All right, so let's answer the question. It said find the complex number Z. Well, Z is A plus BI, isn't it? And we've found the value of A, 29 on 26. And we've found the value of B, 67 on 26. I. Nicely done. Okay, any questions about that? Okay, on to number 3. Okay, wants us to find the complex number Z in simplest form. Now, simplest form for a complex number is just the real part plus the imaginary part, A plus BI. So what we need to do is collect these together and simplify it accordingly. Now, at the moment, they don't have the same denominator. So in order to collect this number and this number, we need to make them first have the same denominator. So there's two ways we could do it. What we could do is make this have a rational denominator and then combine it, or we can make this have a complex number denominator. Let's go ahead and do the second procedure. So what we're going to do is we're going to multiply this second part by 2 take 5i on 2 take 5i. Okay, that term there, by 2 take 5i from 2 take 5i, we're multiplying it by 1, but then you can see it's going to have the same denominator. So I'm going to write what we have next. We're going to have 3 on 2 take 5i plus 4 take I times 2 take 5i on 2 take 5i. Okay? We're going to expand it and collect it all over the same denominator. Alright? So we're going to have 3 plus, and we're going to FOIL here. We've got 8, take 20i, take 2i, plus 5i squared. All on top of 2 take 5i. Okay, 3 and 8 is 11. We've got minus 22i, and then plus 5i squared is plus 5 times minus 1 is take 5. So that's 6 take 22i on 2 take 5i. Okay, halfway. Alright, because, yep, we've sort of combined, what have we done so far? We've just combined those two parts together, but now, to write it in simplest form, we need to write it with a rational denominator, with a real number denominator. So the way we get rid of the complex number at the bottom is by multiplying by the conjugate. So I'm going to come up here to do that. Let's come up here, we've got 6 take 22i on 2 take 5i. And if we're multiplying by the conjugate, we're going to multiply it by 2 plus 5i on 2 plus 5i. Okay, and so the reason we do that is at the bottom, we've got a take b times a plus b. That gives us, at the denominator, it's going to be 2 squared take 5, 5 squared I squared. top, we're going to have to do some FOIL again. Okay, we're going to have 12 plus 30i, take 44i, take 110 I squared. Okay, then we're just simplifying and collecting. So the denominator becomes 4, take 25 times minus 1. At the numerator, at the top here, we're going to have 12 plus 110, which is 122, and then take 14 I. Take 4 plus 25, 29. Okay, and we've expressed it in the form a plus bi. We have the real part and the imaginary part. So, fair bit involved there. Much fun question. Any questions?
It's a bit of
7F.2. We love a bit of fun maths. Let's do it.